When you picture a farm pond, you probably see something just like this, right? A quiet, simple body of water, just a peaceful part of the landscape. But believe me, that simplicity, it's a total illusion. It's a masterclass in disguise.
It's a common thought for sure. But what if I told you that holding back thousands, literally thousands of tons of water with just dirt and physics, well, that's one of the most precise and high-stakes engineering challenges in all of agriculture.
Yeah, it's a high-stakes balancing act between water, earth, and physics. And if you get that balance wrong, it's not just a little leak. We're talking catastrophic failure. So today, let's pull back the curtain and look at the incredible engineering that makes a simple farm pond even possible.
Okay, let's dive into the blueprint. The fate of a pond is pretty much sealed before a single scoop of dirt is ever moved. The success or failure, it's almost always decided right here at the very beginning. The number one most important decision is where you build it, because the land itself, it tells you exactly what's possible and what's not.
So you basically have two main types, embankment ponds and excavated ponds. If you've got a natural valley, you can build an embankment pond. Think of it like plugging a gap with a dam. It's super efficient. You move a little bit of earth to store a ton of water. But, and this is a big but, it's a much higher risk structure. Now, if you're on flat land, you've got to dig an excavated pond. Here, the hole you dig is your storage. It's simpler from an engineering standpoint, but way more expensive when you think about all the dirt you have to move.
Okay, so you've picked your site. You know what kind of pond you're building. But how do you make sure the water actually stays in the pond? That's the million-dollar question, right? What stops it from just soaking into the ground and vanishing? Well, the answer is literally right beneath your feet.
Look at this, 20%. Just that number. What in the world could that be about? Well, this right here is the absolute, non-negotiable secret ingredient for any successful pond.
Yep, that's the minimum clay content your soil needs to form a natural watertight seal. The soil itself has to be at least 20% clay. See, clay particles are super tiny and they stick together. When you compact them, they form this almost perfect waterproof barrier. If you have any less than that, you're basically trying to hold water in a sieve. It's just not going to work. So this one little number, it dictates everything, whether you can build a pond naturally or if you have to go the much, much more expensive route with an artificial line.
All right, so let's say your soil is good to go. Now it's time to build the backbone of the whole operation, the dam. And I want to be crystal clear, this is not just a pile of dirt. It's a precisely engineered structure designed to fight off thousands of tons of water pressure 24/7.
And the very first line of defense is actually invisible once the dam is built. Before anything goes up, engineers dig what's called a core trench right along the center line. They dig all the way down until they hit a solid, impervious layer, like bedrock or dense clay. Then, they fill that trench back up with the best quality clay they can find, compacting it like crazy. What you're left with is a watertight spine that literally locks the dam into the foundation and stops water from ever finding a sneaky path underneath.
Now, this core trench is designed to prevent a very specific and very terrifying type of failure. It's called piping. And what that means is, it all starts with a tiny trickle of water finding a path, either under or right through the dam. That little trickle starts carrying away soil particles, which makes the channel bigger, which lets more water through. And that cycle continues until that tiny trickle becomes an unstoppable torrent that can literally blow out the entire dam from the inside out. It's a total nightmare scenario. So the actual shape of the dam is all about stable slopes. It's pure geometry. The upstream slope, that's the wet side, it has to be really gentle. We're talking a 3-to-1 ratio. So for every foot it goes up, it goes out 3 feet. This spread out design helps it resist getting waterlogged and slumping, and it also handles wave action better. The downstream side, the dry side, can be a bit steeper. Usually a 2-to-1 ratio is fine. But when you add them up, that combined ratio has to be at least 5-to-1 to give the dam enough shear mass and stability. And of course, the top has to be wide enough, maybe 8 to 10 feet, so you can get maintenance vehicles up there.
When it comes to the art of compaction, the strength of an earthen dam really boils down to one thing: compaction. It's everything. Here's how it works. First, you strip away all the organic topsoil. That stuff is weak and spongy. You want it gone. Then, after that core trench we talked about is finished, you start building the dam up. But you do it in really thin layers, what they call lifts. We're talking only 6 to 8 inches at a time. Each and every one of those lifts gets compacted with heavy machinery at just the right moisture level to squeeze out every last air pocket and lock those soil particles together. It's a slow, super meticulous process, but it's absolutely crucial.
Okay, let's talk about the guardian of the pond, taming floods. Look, you can build the strongest, most perfectly compacted dam in the world, but it's completely useless if a massive storm sends a wall of water right over the top. That disaster has a name. It's called overtopping, and it can wash away an entire earthen dam in just a matter of minutes. So, how on earth do you prevent that?
You do it by building a Guardian, specifically a two-stage spillway system. Think of it like this. The principal spillway is for your everyday stuff. It's usually just a pipe or a small concrete box that handles the normal, day-to-day overflow and keeps the pond at its perfect level. But the real hero of the story is the auxiliary spillway. This is your emergency safety valve. It's designed to do nothing until a massive, once-in-100-years flood comes along. Then it kicks into action.
And this auxiliary spillway's job is huge, carrying massive volumes of high-velocity water safely around the dam. I have to stress, this is not just some ditch they dug. It's a carefully engineered channel, sometimes a big concrete chute, and it's always built into solid, natural ground right next to the dam, never on the dam fill itself. Its one and only job is to give that floodwater a safe exit path so it never ever touches the top of that earthen dam.
I mean, this creates a whole new problem, right? You've now got this massive volume of water, basically a river, accelerating down a steep slope. That water has an incredible amount of destructive energy. If you just let it rip, it would carve out a huge hole at the bottom and could undermine the entire dam's foundation. It'd be a total disaster.
Well, the solution is just a brilliant piece of physics called a hydraulic jump. It's so cool. At the bottom of the spillway, engineers build a special concrete basin called a stilling basin. What this structure does is it forces that super fast, shallow water to suddenly slam into a deep, slow-moving pool. That sudden transition creates this incredibly violent, contained turbulence, a hydraulic jump, and that chaos safely burns off all the water's destructive energy before it can do any harm downstream. It's genius.
All right, moving on to the finishing touches, sealing and securing the pond. So what happens if your site just doesn't have that magic 20% clay we talked about? Well, you're not out of luck. That's when you have to turn to artificial liners to create that crucial waterproof seal.
And you've got a few different options here. You can literally truck in and compact a thick layer of good clay, which can self-heal but is a ton of work. Or you can use something called bentonite. It's a natural clay that swells up like crazy when it gets wet, and it's great for sealing up sandy soils. But for a virtually guaranteed seal, you go with a geomembrane, which is just a fancy word for a big synthetic liner. You've got HDPE, which is super durable and chemical resistant, but kind of rigid. And then you've got things like LLDP or RPE, which are more flexible and puncture resistant, making them a better choice for uneven ground.
But installing one of these geomembrane liners is no joke. It's a precision operation. First, the ground underneath has to be perfectly smooth, almost polished. Any sharp rock or root will be a future leak. Then you roll the liner out with some slack in it so the weight of the water won't stress it. Where the big panels meet, they're heat welded together with a special machine that actually creates a little channel you can pressurize with air to test the seam. It's amazing. And finally, you bury the edges all around the perimeter in what's called an anchor trench to lock the whole thing in place.
And you know, a pond's work is never really done. Just because the construction crews have packed up and gone home doesn't mean the job is over, not by a long shot. A pond is a living, dynamic structure that needs constant care. You have to keep the dam mowed so you can spot any issues like cracks or animal burrows. Trees are an absolute no-go on the dam. Their roots can rot and create little pathways for water to seep through. You have to protect the shoreline from getting chewed up by waves, usually with big rocks. And since ponds are basically giant sediment traps, eventually you're going to have to dredge it out.
So when you put it all together, from the blueprint to the backbone to the Guardian, a farm pond is so much more than just a hole in the ground. From that initial site selection and checking the soil, to the precise geometry of the dam, the crazy complex hydraulics of the spillway, and even the meticulous installation of a liner, it's a true masterclass in managing the forces of nature.
So yeah, a simple pond is actually a complex machine built from nothing but earth and water. It really makes you think, doesn't it? What other simple things are all around us, things we see every day, that are hiding a whole world of mind-blowing engineering right under our noses?